Yo, what's up, guys? Mr. Phil here. We're going to talk about fractions today and the basic idea of fractions. I'm going to put some videos or make some videos later for all the different operations. Let's just talk about what fractions are. So this was a little tough to think of what I was going to write and what exactly I was going to present to you guys, but let's just talk about fractions in general. What is a fraction? It's a quantity, it's a value, usually in between 0 and 1. Not that it must be in between 0 and 1, but that it represents a value in between 0 and 1. What does that mean? I'll show you in a little bit. So 1 over 3, that's how you read it, or 1/3. And this line, this fraction line, actually represents division. This fraction represents the quantity of 1 divided by 3, which if you do the math or you enter it in a calculator, you will see it equals 0.333 forever, and we usually write a line over a repeating part of a decimal, which you could just write 0.3 repeating over here. So the reason why we use fractions is because if you're going to calculate something like 1/3 plus 1/4, 1/3 is not a very nice number to solve for like this or calculate and then add. Who wants to write 0.33333 forever and then plus 1/4 or plus 0.25 if you convert to decimals? Actually, you can't accurately add that unless you change this to 0.33 or somehow adjust the number so that you can calculate it, because this goes on infinitely. So 1/3 plus 1/4 is much more easy to calculate, and that's why we use fractions. So the basics of fractions are, I would say, two main ideas. It's the idea of simplifying improper fractions or reducing fractions. So what is an improper fraction? Well, if you see here, the top is called the numerator. That's the fraction bar. And then the bottom number is called the denominator. So when we have something called an improper fraction, that is when the top number is bigger than the bottom. So in this case, 4/3 is bigger, so that's improper. A fraction like this, where the top number or numerator is smaller than the bottom number, that is a proper fraction. We prefer fractions in this form. So what do you do if the top is bigger than the bottom? Well, I would like you to think of it as a division problem. If you can think of 4 divided by 3, that's exactly what you need to do to solve or change this improper fraction into a proper fraction or mixed number. So 4 divided by 3, you can say is 1 with a remainder of 1. And we want to think of the idea of remainders instead of decimals again because we're going to be using fractions. So the only thing you're going to do different with the fraction part in changing it to a mixed number is you're going to write the same numbers but slightly differently. So your answer, the quotient, becomes a whole number. And then you're going to use the same denominator or bottom number that we had over here, so that doesn't change unless we have to reduce at the end. And then your remainder becomes the new numerator. So you convert 4/3 to 1 and 1/3 using division. Very simple idea. Let's try another one, maybe with some slightly bigger numbers. How about if we do 15 over 2? So 15 divided by 2 is 7, remainder 1. Hopefully you can do that quickly. If you can't, you can see how that skill and speed with that division and quick mental math can be very advantageous when you're doing something much later in your academic career, like adding or subtracting fractions or just dealing with fractions. So again, we're going to write the quotient as the whole number. Our remainder goes on top, and then our denominator is always the same as what we started with. And then we check to see if we can reduce, which we cannot. So those are the basics of changing an improper fraction to a proper fraction. The next topic I'm going to talk about is reducing fractions. So this is what we're going to do. We're going to take something that's a slightly bigger number, 10 and 15, and we're going to see if we can shrink them down. And the reason why this is important is because if we can change the way a number looks, a value looks, while still maintaining the same value, then it's going to be much easier for us to calculate with smaller numbers. So that's why we reduce. The way that you do that is you need to find a number that can divide into the numerator and the denominator evenly. So to give you an example, can you divide 10 by 3 evenly? You cannot, because 10 divided by 3 will give you a remainder, correct? So we never want to reduce by a number that will give us a remainder. So what can we do to find that? Well, a good exercise is to find if there are any common factors of 15 and 10. 10 is 2 times 5 and 1 times 10. 15 is 1 times 15 and 3 times 5. So if you notice, we did 2 times 5 here, 3 times 5. That means that you can reduce by 5 because they have that common factor of 5. So what I like to do when I first start off learning this is have students write 10 divided by 5 here and 15 divided by 5 on the bottom, keeping in mind that this number on top and this number on bottom must always be the same. You're never going to reduce by one number on top and then a different number on bottom. So once you write that out, all that's left to do is the actual math. So using purple, we'll say 10 divided by 5 is 2, and then 15 divided by 5 is 3. So back to my point here where this value, 10 over 15, is equivalent to 2 over 3. If you put those into a calculator, you'll find that both division problems, 10 over 15 and 2 divided by 3 or 2 over 3, will get you the answer of 0.6 repeating. So the values are equivalent, but if you see, this number is much smaller than 10 over 15, and that can be very useful to us. So anytime we can reduce, we should, because if it's our final answer that we need to reduce, if we do not reduce, then we cannot. Or our answer is not correct, sorry. If we can reduce, just to be clear, then our answer is not correct. We must reduce in order for our answer to be correct. It must be simplified as far as you can go. So you should always, even if you reduce and you get an answer like this, you should always check to see if you can reduce any more. It's always just a good thing to do. The second part of it is, let's say we have to add or subtract fractions that are in this form, 10 over 15. Well, it's much easier to get common denominators and subtract or add if we have smaller fractions to deal with anyways. So it's just a good thing to always check, can I reduce the fractions that they gave me? And then when you finish the problem, see if you can reduce your answer at the end. So those are the two main basic principles of working with fractions: learning how to change improper fractions to proper fractions, and learning how to reduce. Now, the last thing I'm going to talk about here in this video is just how to go backwards now. So we learned how to go from 1.5 to 3 over 2, correct? We multiply the bottom number times the new mixed number and then add the top, 3 over 2. So that's how you go from a mixed number to an improper fraction. Before, we learned how to go from 3 over 2 to 1.5. It's just the opposite operation. Instead of dividing 3 divided by 2 and getting answer of 1 remainder 1, right? Like we talked about, and then just writing that as the quotient is the whole number and the 1 is the new numerator, the denominator stays the same. Do you see how we ended up with the same answer? It's very important to learn how to do these two things, go from improper to proper, proper to improper. So just to reiterate, to take a mixed number and change it to improper, instead of dividing, you're going to multiply. You multiply the whole number by the denominator and then add the numerator. So 2 times 3 is 6, plus 2 is 8. That becomes the new numerator. The bottom denominator stays the same, and that is it. Sorry if it was a little confusing in the beginning. I was trying to think of what I wanted to say, and just so you know, I do these videos pretty much in one take, unless I make a really egregious error and have to go back and like kind of edit in a correction. So just to be clear, this is how you go from a mixed number to improper fractions. In the beginning, we learned how to go from an improper fraction to a mixed number. So the terminology matters. These are the same types of terms you're going to hear from your teachers in school. So just make sure you can follow these steps by putting them into practice. These are the type of things that you're going to need to know how to do very quickly, because they're just building blocks for the operations of fractions. So hopefully you can take these ideas, put them into practice, see what they can do for you. Hopefully you get good results. I wish you the best of luck, and I will talk to you soon.